Okay, hi everyone. So in the previous video, I outlined how we obtained trig values of special angles, specifically the 30 degree, 45 degree, and the 60 degree special angles. All right. In this video, I'm going to show you how you can easily uh, reproduce a chart, a table of those values, okay? So the first thing I'm going to do is that, and then I'm going to introduce you to the idea of what's called reference angles. And you're going to need to know those reference angles in order for you to answer questions like this, where they're asking you for angles that are 240 degrees, for instance. Okay? So let's go back here. All right, now, what I want you to do is copy this table along with me. So we're going to put our 30 degrees, our 45 degrees, and 60-degree angles like that. All right. And then on the side, we're going to put our sine, cosine, and then our tangent. Okay, extend it a little more. And then we'll make a little table like this. All right. So all right, so now you have this table, 30, 45, 60, and then sine, cosine, and tangent. Now, what I want you to do is I want you to put fraction bars like this on the first 6 boxes. Okay? And then I want you to put a denominator of 2 like this under all of them. Okay? Now, we're going to count from 1 up to 3. Okay? In ascending order. So 1, 2, 3. And then I'm going to count backwards. 3, 2, 1. So count up for the sine. So 1, 2, 3. And count down for the cosine. 3, 2, 1. And then we're going to put radicals on just the numerators for all of them. Like that. And there you have your first 6 values for the sine and cosine of 30, 45, and 60 degrees. Okay? Now tangent, if you remember, tangent was a little different, right? So tangent of 30 was radical 3 over 3. Okay, remember? We found that out in the previous video. And then the tangent of 45 was just 1. And then the tangent of 60 was just radical 3. Okay? So the values for tangent are really the only ones that we kind of had to memorize. Otherwise, for sine and cosine, all we have to do, again, is put 2's in the denominator, count up 1, 2, 3, 3, 2, 1, and then put radicals on the numerators. And that's it. By the way, what's radical 1? Radical 1 is just 1, right? So you could have just written this as just 1 over 2. And same thing over here for the cosine of 60. That's just 1 over 2. Okay? But it's not wrong if you put radical 1 over 2. It's still correct. So this is an easy way for you to memorize the sine, cosine, and tangent values for these special angles, 30, 45, and 60. Okay, guys? Now, as I said before, so you also have to know this concept of what we call reference angles. All right? So I'm going to show you what reference angles are. Okay? You have to know what these reference angles are so that we can find the sine, cosine, and tangent of angles that are not 30, 45, or 60, but that they are related to the 30, 45, and 60 degree angles. All right, so here we go. So, reference angles are definition. Okay. So reference angles are angles formed by the terminal side and the x-axis. Okay, and they relate something. Okay, they relate to the acute angles in quadrant 1. Okay, so when we have so basically these are angles formed by the terminal side and the x-axis. All right, so when we have let's draw some angles here. The x and here's the y. So basically when we draw an angle, okay, the initial side of the angle, remember an angle always has two sides, right? So here is the initial side. That is always called the initial side, okay? Initial side. And the initial side is always on the positive x-axis. Positive x-axis. Now, basically what creates the angle? It's the terminal side. It's the side that's moving. So, for instance, I'm going to draw a terminal side like that. Okay, this is our terminal side. That's the terminal side of an angle. Terminal side. Okay, the terminal side is the side that rotates, basically. Okay, that's the side that rotates around. Okay, the origin, creating that angle theta. So there's your angle theta, right? And the angle theta has an initial side that's always on the positive x-axis. And from the positive x-axis is how we measure the angle. Okay, so as this terminal side continues to rotate around the origin, right, continues to rotate, it's going to give the measure of our angle theta. And this terminal side can be anywhere. It can be anywhere on this unit circle. Okay, imagine again, this is part of the unit circle, right? So this terminal side could be in quadrant 1, it could be in quadrant 2, quadrant 3, or quadrant 4. Okay, now the only thing that you really have to remember is that, which is important, is that the reference angles are always formed by the terminal side and the x-axis. Okay, so for instance, let me show you an angle like this. I show you an angle. Okay, so let's take this angle. Again, we have our initial side is on the positive x-axis, correct? That's our initial side. Okay, our vertex is always on the origin. And then here is our terminal side. Okay, so initial and terminal. Okay, so in essence, this angle right in here, here's our angle theta. The angle is formed by the initial and the terminal, correct? That's our angle theta. However, this angle theta, as you can see, is a obtuse angle, right? It's an angle that's greater than 90 degrees. So then what would be considered our reference angle? Well, the reference angle is always formed by the x-axis and the terminal side. So in here, the x-axis, and by the way, it's always an acute angle, so I should have mentioned that. Okay, so the reference angle is always an acute angle, is always acute. Okay, is always acute. Reference angle is always acute, which means, okay, it's between 0 and 90, right? So between 0 and 90 degrees. Okay, so in this particular picture, our reference angle is an acute angle formed by the x-axis and the terminal side. I'm going to show you what that is. Okay, x-axis and the terminal side. Okay, like that. So here is our reference angle. This is called our reference angle. Okay, so an angle that's formed in the second quadrant, like this angle here, right, where the terminal side is now in the second quadrant. This is what the reference angle would look like. So let's give an example. Let's say that theta, was equal to, and I'm going to pick an obtuse angle here. So let's say that was 130 degrees, 120 degrees. Okay, so let's say we have an original angle of 120 degrees. Well, then what would our reference angle here be? Okay, our reference angle, okay, sorry, so this was 120, right? So this was 120 degrees. So if our angle theta is equal to 120 degrees, then our reference angle would be what? It would be, this is 180 here, correct? So our reference angle would be 180 minus 120, which is equal to 60 degrees, right? So our reference angle here is equal to 60 degrees. Okay, now let's pick another angle here. This is our Q, this is a Q2, quadrant 2 angle. Let's look at a quadrant 3 angle here. Erase this part so we make some space. So let's say we have another angle, this time in the third quadrant. Here's X, here's Y, and now I'm going to draw an angle. Excuse me. Let's draw an angle in the third quadrant. Like that. Again, an initial side always on the positive x-axis, and our terminal side, right, in the third quadrant. This is a Q3 angle. So in a Q3 angle, our angle goes all the way around like this. Okay, that's our theta. This is our theta. So I'm going to call this theta, excuse me, let's call that 210. Okay, our original angle is 210 degrees. Question, then what's the reference angle? Where is the reference angle? Again, by definition, a reference angle is an acute angle. It's between 0 and 90, and it's formed by the x-axis. It's formed by the x-axis and the terminal side. Okay? So here is our terminal side. Here is the x-axis. So our reference angle is right in here. Okay? Which means that the reference angle is formed, this is 180 here. So to find the reference angle, we would have to take 210, subtract 180 from it, and we would get our reference. Okay? So 210 minus 180, and that gives us 30.